Everything you have been told about cortisol is wrong, not slightly wrong, fundamentally wrong. Cortisol is not the stress hormone. That is like calling fire an oxygen problem. Cortisol is one of the most sophisticated pieces of biological engineering your body has ever produced. And what it is actually doing inside your brain right now, in the amount of time it takes you to read this sentence, is almost nothing like what you have been taught. This is not about stress being good or bad. This is about what is actually happening. The chemistry, the architecture, the precise sequence your brain runs every single time it decides your life might be on the line. Because here is the thing. Your brain has been running this sequence your whole life, every single day, and you have been told almost nothing accurate about what it is actually doing. But what cortisol is actually doing to the structure of your brain, that is the part they never told you about. Your brain weighs about 1.4 kilograms. It uses 20% of your body's total energy supply every single hour, while taking up less than 2% of your body mass. Think of it like this. If your body were a city, the brain is the single building that consumes 1/5 of all the electricity, constantly, without pause, even while you sleep. And inside that brain is a structure the size of a curved thumb, the amygdala, whose entire job is to scan everything you experience and ask one question over and over, thousands of times every day. Is this a threat? When the amygdala decides yes, something extraordinary happens. Everything in this video is for educational purposes only. Always talk to your doctor before making any changes to your health or lifestyle. Body Vault AI uses AI-powered 3D visualization to explain what science already knows about the human body. We are here to educate, not prescribe. Your hypothalamus, a region no larger than an almond, fires a signal to your pituitary gland. The pituitary fires to your adrenal glands, which sit on top of your kidneys, and within moments, cortisol enters your bloodstream. That entire sequence, amygdala detection to cortisol release, takes under 2 minutes. The cascade that follows rewrites your entire physiology. Your pupils dilate, your heart rate climbs, your digestive system powers down. Blood flows away from your organs and toward your large muscle groups. Your immune function dips. Your memory consolidation slows. Glucose floods your bloodstream. This is not a metaphor. This is a 14-step physiological protocol your body runs with the precision of a flight computer every single time the amygdala fires the alarm. So what exactly happens inside your brain in the 90 seconds after a stress trigger fires? Because the sequence is stranger than anything you learned in school. Here's the thing most people get wrong about cortisol. They think it is the problem, that it is the enemy, that the goal is to have less of it. That is like wanting less of the mechanism that stops you walking into traffic. Cortisol does not create the danger, it responds to it. Brilliantly, precisely, rapidly. In the first 20 seconds of a cortisol surge, your brain does something extraordinary. It temporarily mutes your prefrontal cortex, the part of your brain responsible for long-term thinking, nuance, consequences, and doubt. Think of it like this. If you are being chased, you do not need to consider the ethical implications of your route. You need to run. Cortisol makes sure that happens by temporarily shutting off the part of your brain that might slow that decision down. At the same time, it sharpens the amygdala, your threat detection center, to razor precision. Your pattern recognition becomes hypersensitive. You see threats faster. You hear threats at lower volumes. You respond to them sooner. This is not damage. This is calibration. Did you know cortisol reaches peak concentration in your bloodstream in under 90 seconds after a stress trigger? And it can stay elevated for up to 3 hours, affecting every organ in your body throughout that entire window. 3 hours from a single email, from a single argument, from a single moment of uncertainty. That is the scale of what cortisol actually does. Now here is where it gets more interesting. Your hippocampus, the seahorse-shaped structure that converts your daily experiences into long-term memories, is lined with cortisol receptors. More than almost anywhere else in the brain, this is by design. When your brain decides something is dangerous enough to trigger cortisol, it wants that experience remembered. urgently, permanently. The mechanism, cortisol, activates long-term potentiation across hippocampal synapses, strengthening the neural pathways associated with the threatening experience. The same biological process that builds skill and memory is used here to burn a threat response into your neural architecture. That is why traumatic memories feel so vivid. It is not an accident. Cortisol insists on it. But here is where the science gets genuinely surprising, because what researchers discovered about the hippocampus and cortisol changed how we understand memory itself. What the research showed is this: short-term cortisol, the kind that fires during a real threat and resolves, actually strengthens the hippocampus. It makes memory sharper. It improves the very architecture it acts on. But chronically elevated cortisol, the kind that stays elevated day after day because the stress trigger never fully resolves, does something different. It begins to suppress neurogenesis in the hippocampus. Neurogenesis is the process of building new neurons, new brain cells. Your hippocampus does this continuously throughout your life, and it depends on cortisol staying within its normal range. When cortisol stays chronically elevated, that building process slows. Think of it like this: your brain is trying to add new rooms to a building while someone keeps cutting the power to the construction site. Eventually, the building stops growing. Research has found associations between chronically elevated cortisol and reduced volume in the hippocampal region. Studies suggest the mechanism involves exactly this: suppressed neurogenesis combined with reduced dendritic branching in existing neurons. This is where memory difficulties under sustained stress come from. Not from being tired, not from distraction, from a structural change happening inside the actual tissue. Did you know that research has found associations between chronically elevated cortisol and reduced hippocampal volume, the brain region responsible for converting short-term experiences into long-term memories? Scientists believe this is part of why some people under sustained stress find it harder to retain new information. This is 0.1 millimeters, the width of a single synaptic connection. The physical change that sustained cortisol produces in the hippocampus happens at this scale, in the gap between one neuron and the next. Now here is what most explanations miss entirely. Your cortisol response is not designed to be suppressed, it is designed to be completed. The cascade your amygdala fires was built for a physical world. Chase, fight, climb, sprint. The sequence is threat detected, cortisol released, physical action taken, cortisol metabolized. The problem in the modern world is that the fourth step almost never happens. You feel the cortisol surge from a difficult meeting. You suppress it, sit with it. Think about it on the way home. Let it circulate. Cortisol was never designed to be sat with. It was designed to be burned. And what scientists only fully mapped in the last decade, the specific mechanism that ends a cortisol response faster than anything else, changes how you think about every stressful moment you have ever had. Here is the fact that stops most people. Your body does not know the difference between being chased by a lion and being late for a meeting. That is not a metaphor. Cortisol triggers the same 14-step physiological cascade in both situations. The same pupils dilating, the same digestive shutdown, the same glucose flooding your bloodstream. Your brain is running the same emergency program it has been running for 200,000 years. Every time your inbox is overwhelming, every time you are 3 minutes behind schedule, every time someone sends you a message you do not want to read, and the cortisol that was released in response to that email is now circulating through your bloodstream, looking for a physical action to complete. Some research suggests that completing a physical movement, running, shaking, vigorous walking, helps metabolize cortisol more efficiently than cognitive suppression alone. The idea, your cortisol response was designed to end through action, not through stillness. The same mechanism that sharpens your threat response also shapes which memories survive long-term. High cortisol experiences have a higher probability of consolidating into long-term memory. This is why negative experiences can feel permanently lodged while positive ones sometimes fade. The hippocampus was given explicit biological instructions about what to keep. Did you know completing a physical movement, even a brief vigorous one, has been explored in some research as a way to support cortisol regulation. Your stress response was designed to be completed through action. Suppression was not part of the original design. Some people find, and this is not a prescription, that the feeling of cortisol does not need to be fought. It needs to be finished. Not with a breathing exercise, not with a podcast, with the same thing it has always asked for: movement, completion, resolution. Which brings us to what surprised us most when we went inside the stressed brain, and why it changes the way you think about every difficult moment. Cortisol has been running this program in your brain since long before language existed. It does not know you have a calendar. It does not know the threat is an email. It does not know the chase is already over. It only knows the alarm fired, and it is waiting for the action that completes it. That is not a flaw in your biology. That is the most exquisitely calibrated survival system your body has ever built, running, as it always has, in exactly the body you carry right now. Now you know what it is actually doing. Next time we are going inside the gut, and the network of neurons we found there is one of the strangest discoveries in modern neuroscience.